Hey everybody, this is the Fusion 360 tutorial for the TCOSE-012, what I called A. So it's the lever arm section of the TCOSE 12 part. This is a fairly simple part, and we're going to be doing this part with one tool and two operations. So we're going to go over from design. Once you have your part running, we're going to go to from design to the manufacturer workspace. You need to select the setups on the left on your browser and the setup icon. This is where we're going to be making our setup to machine the part. What we need to start with is actually the middle tab, which is the stock tab. And on our stock on sides, we're going to put a 1/2 inch. And then on our top, we're going to put 0. The material is 3 millimeters thick, and we should be able to buy brass in that thickness. We don't need a bottom offset, and we don't need to round to the nearest. So our stock we're going to cut this part from is roughly an inch 600 thousandths by 2 inches 400 thousandths. We're going to go back to the setup tab, and we're going to orientate in the screen as if the long direction is an X in a machine. I'm in the habit of that because most of the milling machines, the X travels longer than the Y travel, and if you switch machines, you may set something up that's too big for the Y travel. In this case, it's a tiny part, so it's somewhat academic. Okay, we're going to switch from model orientation to Z-plane and X-axis. So we want to select the top of the part as our Z plane that we're going to be normal to. And our X-axis, we're going to pick on what is the world coordinate Y-axis. Okay, and we should have our trihedron rotate as shown here. Now we're going to select the point, and we're going to use the back left corner as our origin for our work coordinate system. Moving on, we're going to go to post-process, and we're going to use a naming convention. This is going to be 12 for the part, and we're going to call it 01. Now we're not allowed to use letters, so when we do the B part, we're going to need to keep that in mind for the part number. Okay, and this would be operation 1 with a work coordinate system of 1, which is the first one. We select OK, and I'm going to change this to setup 1. It defaulted to 2 for me. Now's a good time to save. Alright, so now we're going to do a contour on this hole, and then we'll come back and cut the outside profile, leaving a little bit of material to keep it connected to the surrounding stock. If we were to inspect this hole diameter, it is a diameter of 197 thousandths, or 0.197. So we should be able to get in there with a 16th end mill, which is 62 thousandths in diameter. So we're going to go to 2D contour. We're going to go to the TCOSE library. We're going to select tool number 5 for a 16th inch flat end mill. Select OK. And let's bump the RPM up to 5,000. Actually, let's bump the RPM up to 6,000. It's a small cutter. And we're going to go at a feed rate of 7.2 inches a minute on everything. That is currently at 39. It's way too fast. And then on our plunge rates, we're going to go to half of that. So let's do 4. It's a small cutter. We don't want to break this thing. Our contour we're going to select is the circle. You want to rotate it in 3D to make sure the arrow is on the correct side of the circle. So we want it to cut on the side the arrow is within. If it's on the wrong side, just pick on it and it'll flip to the other side, like that. Okay, and then we're going to go to heights. We're going to leave all of our heights at default. We're going to move on to passes. We want to go left. We want wear compensation. And then we're going to go down to roughing passes. We're going to select roughing passes. We're going to set our maximum step over of 20 thousandths. You can leave the other ones at default. We want one roughing step. Now once you select this box, it's not intuitive, but another box appears up here, and this is your finishing step over, what's left for the finishing cut. Let's set that at 5 thousandths. This is a fairly small feature. And we're going to do multiple depths with a maximum step down of, let's do 0.02 as well. And I'm going to hide some of the path information here so you can see it. We're going to do 2 finishing step downs. I'm sorry, 1 finishing step down. And our step down increment is going to be 0.05. We're going to finish only at final depth, and we're going to use even step overs. And we're going to go to this, we're going to skip stock to lead, we're going to go to smoothing, and we want smoothing turned on at 4 tenths. Next tab, leave everything up at the top at default. And I think we'll leave the lead-ins and the radiuses at default, but we're going to take off the vertical lead-in. We don't want one. So let's hit OK. And we get several rough passes and a finished pass at final depth. And we go to arc ends and arc outs. Now, I'll show you something. We can now copy this toolpath and use it for the outside. And we'll just change a few parameters. We're going to right click on it and select duplicate. Now we have 2 2D contours with the same information. Right click on the new one, hit edit. We'll leave everything on the first tab the same. The second tab is going to change because we're going to select different geometry. We're going to select out here. You want to rotate, make sure the arrow is on the correct side, which it is. We're going to go to heights, and we're going to change one thing on here. We're going to leave everything at default except for this last tab here. We're going to put in 0.005. We're going to leave a little bit of flash to leave it connected to the surrounding material. Now we go to the heights tab. Everything on here stays the same, and on the linking everything stays the same except we're going to select an entry position. So the entry position sets where the cut's going to start, and we want to have that where the operator can see it. So instead of being in the back of the part, we want to force it to be on the front of the part. So I'm going to pick this location here, and that'll force the initial plunge to be towards the operator where they can see what's going on. This is pretty important on big parts. Let's hit OK. And now that we processed, we started here, you still have your arc in and arc out, and it should leave, in this view, a little bit of material and go all the way to the bottom. Alright, this is a short program. It's not a real big deal, but I am going to do a best practice, and we're going to name these. So our 2D contour, the first one is the hole. And our second contour is the profile. And that'll show up in our post-processed code. Alright, let's save. Okay. Okay, and we're going to simulate. So make sure your setup is highlighted. You can see the stock. And go to simulate. You want to make sure this box down here that says stock is checked. And we're going to hit play. So it comes down. Machine's the first hole. Doing all the rough cuts, and it comes around and does a finish cut on the sides. And now it's going to come around and do the outside perimeter, leaving 5 thousandths to be removed by the finish cut. So I just hid the holder so that we can see what's going on. Okay. And according to that simulation, this program will take 4 minutes of machine time. Okay, so after you've simulated, you're going to want to do your setup sheet. So it's this icon here. Make sure you have your setup that you're doing the setup sheet for highlighted. Select the destination for it. And you should have a setup sheet that looks like this. Now, something to think about is make sure the model is displayed in a way that whatever the current view is going to show the orientation as if the operator sees it with Z pointing up on the spindle. Alright, check for red flags like RPMs or feed rates that are too high. Then you're safe to post-process. This should be all set up at default pretty much. It'll pull in the program number you put it in the beginning, and you need to have a destination folder where you know it's going to go, and you're using the HOS pre-ngc/HOS post-processor. Alright, if it's not showing that, you need to select Open Configuration and find that post-processor. If you have this box checked, the code after you hit post-process and save will show up in a text format like this, and submit the .nc file, which is the extension for the file for the code, and either an HTML or PDF version of the setup sheet for each program. Now, this one only has a single setup, single program. Alright, we're done with this part,
And I'll catch you on the next one.